Welcome to this tutorial. We will convert MRI data to a compatible 3D mesh for FEniCS. All the links you need are in the description for the library and for the neuroimaging data. First, the Nibabel library allows you to read a nifti file format with a Python script, and all the information you need are in the nifti header. You see the dimension of the nifti file, how many slides for each dimension. The 4 dimension is for time series. Here is a pixel dimension, 1 mm in clinical unit, and here is the basis for the Numpy array. When you have your Numpy array, we go in the GMSH FEniCS version. We launch the Docker, and during the execution of the script, we will see the code. Here we have all the maximum and minimum of each dimension retrieved from the nifti files. Here the length you choose, 3 mm here. And with the Mesh.io library, we construct the mesh. Here the edges, and here the cells. Thank you to Davide Baroli for this one. GMSH finished its optimization, and okay. When we have the GMSH box just made and the Numpy array from the nifti files, we will collide the 2 files. Here the script. Here we retrieve the box we just made with GMSH, and here is the label from the nifti files. We first initiate the box tree algorithm for the computation of distance in FEniCS, and for each label we'll do the same thing. Retrieve the 3D point, and with the methods compute closest entity, we'll find the closest cells for the mesh, and mark it with the label. You may want to refine the boundary between 2 phases, and here you have a Boolean function on each cell. We initiate the connection between the edges and the cells, and for each cells we will test each entity. We will test if we have different neighbor, and we mark the cells as true. We initiate a second mesh and affected the refined one. After this, we'll redone the whole process for each label. The whole process takes 10 minutes. So, let's see what we have. First, the label of the gray matter. Okay, just tune the opacity. The CSF phase. Just make some slice in sagittal and axial plane to see what is it inside. Okay. And the vessel phase. Yes. We have what we want. Hope it will be useful for you. Thanks for watching.